unlimited scientific libraries and applications in Kubernetes or OpenShift instantly. Hi, my name is Guillaume Moutier, and I'm a data engineering architect at Red Hat, working mostly on data science platforms and solutions. The title of this presentation sounds interesting, and I hope that's why you are watching it. But of course, we first have to understand why someone would want to do this. So, let's say you have been tasked with building an on-demand data science platform based on containers. First thing you would want to provide is of course some kind of notebook-as-a-service solution. You would surely create a base image like this one. It would include Python, a set of libraries your users may need, and of course Jupyter. Your first users are really happy with it. They have a quick access to a consistent environment that they don't have to manage, so they can concentrate on their work. That's perfect. But after some time, those users will surely ask for some customization. Like, instead of this version of a library that comes with your base image, they want another one. Or, instead of doing pip installs inside their environment to add libraries that are missing, they want to have their favorite ones directly baked into the base image. So, let's look at some of the options you have. A first one would be to create a new image with those missing libraries. Of course this works, you have everything you need. But then the image size can get really huge, making it almost impossible to work with. And you can only have one version of a specific library in an image, which may be a problem if different users ask for different versions. Another option would be to create as many custom images as needed to accommodate all the requests and needs. You would mix and match libraries or versions. This would be great at the beginning, but after a few months, you will surely end up with tens, if not hundreds, of versions of images to create, maintain, and from a user perspective to choose from. That's not really practical at scale. Last option is in fact doing nothing, and let the users do their own installation of the packages they need. However, it defeats the purpose of providing a ready-to-use and consistent environment. It may also not work in a disconnected environment. Finally, if you need to install OS packages, this won't work in an enterprise environment like OpenShift, where containers don't run as root, and users are not allowed to do those yum installs or apt-get commands. So, what can you do? What I will present here is an elegant solution that will use different open source projects together. The idea is that instead of building the needed applications and libraries into the container images, you can store all of them as modules in a read-only shared library hosted on an ARX volume, which means it's read-only but can be accessed by many pods simultaneously. Then you simply have to mount this volume inside the notebook pods at spawn time. And finally, leveraging Linux environment modules with lmod, it gets easy to dynamically load what you need when you need it, instantly. Let's see this into action. Here, as you can see, I am in my browser and I am on the Open Data Hub dashboard where I have access to different data science tools that have been installed by Open Data Hub. And I'm going to first put this full screen so that you can have a better view. And I'm going to launch my Jupyter environment. So I will click here on launch and I can start a notebook server. Okay. In my case, I will use a spatial image, the standard data science modular. That is a spatial image that I have created that is able to load those modules. Okay, so it is able to connect to this shared library and to load modules, as we're going to see in a few seconds. Okay, of course, in the launcher, I could choose the deployment size, so the size of my container image, put on some environment variables. But here for this demo, we will just start the server. So what happens behind the scene is that on my OpenShift environment, I have a pod that is spawned directly with my notebook image. It is reattaching my persistent volume with all my data and everything. And in a few seconds, I will have access to my environment. And now my server is ready. So remember, it runs in a fully containerized environment on my OpenShift cluster, and I have been reconnected to my personal data, to my volume. In my case here, I'm already in my demo notebooks folder, where I have a few things to show you. So we can start an example with PyTorch, and here I have a notebook that I have created that allows you, when given an image of a dog, to determine using an AIML model which kind of breed it is. Okay, so we're gonna launch the first cell. Perfect. Then the second one. Oh, and you can see we have a problem because it starts with import torch vision. Well, it seems that in my containerized environment I don't have torch vision. Okay, so of course I could do what we discussed earlier, do pip install and everything, but here with this new modular approach, I can go here to my software extension and search among the different modules if I have something that match the torch vision thing. Oh yeah, in my featured models, you can see that I have torch vision here at version 0.10.0. Perfect, seems to be something that would work for me. And I can just click on load. Okay, it takes a few seconds, so it's even quicker than pip install and everything. And you can see that it has loaded torch vision, but also all the dependencies that I need for this to work. Okay, so now my module is loaded, and what I can do is simply restart my kernel, okay, and we'll go again with my cell. You have to restart the kernel, of course, to reinitialize the environment variables and everything, and you can see that this time torch vision has been found and everything. So we're going to run all the cells that are below here, and you can see that it has loading a picture of my dog, Peter, who is Leonberg, and you can see that the model has detected that indeed there is a good chance that it is a Leonberg. So that's perfect. So you can see that I didn't have to install anything on my environment. I just had to select a specific module that I wanted to load. Okay, I could do the same for Torch Audio, for example. Okay, let's load this module and see what happens. You can see, okay, it has been loaded. That's perfect. But what happens when you unload a module? Let's say you unload Torch Vision, which you don't need anymore. Okay, it came with some dependencies that are the same one that are needed by Torch Audio. So let's see what happens. We do this unloading thing, and you can see that, well, obviously Torch Vision has been unloaded, but Torch Audio is still there with all the dependencies, which are the same one that were needed by Torch Vision. So here the mechanism, the engine, keeps a trace on which modules needs which dependency, and keeps tracks on what to load and unload depending on what you want to do. So let's do this. We're going to unload Torch Audio, and you can see that there's nothing loaded anymore here. Okay, I will remove my filter, and you can see that those are the different modules that are available. And as you can see, there may be some different versions for the same module. So here we have a module with R at version 4.0.5 or R at version 4.1.0. So you can have many different versions of of a library that are available as module, and you can choose to load whatever you want depending on your need. And R is a good example because here you can not only load Python modules or Python libraries, but you can also load something that is completely different. So for example, here I will load an R kernel that I can use directly inside my environment. And let's do this with R version 4.0.5. I will load the kernel, and you can see now that my kernel is available in my launcher, meaning I could launch directly a notebook that is running on an R engine. Okay, so you can totally mix and match your environment with this. I'm gonna close this one. You can even go further and load full-blown applications. Let's do this with our studio server, okay, which is something very popular. So I can again, click on load on my module, and it will automatically appear in my launcher. Okay, so now I have access to RStudio, and I am able to click on it. I will just go back from full screen, and you can see that it has opened a new tab where I have access to my RStudio environment, and you can see that it's indeed the same environment. I have been reconnected to the exact same persistent volume, because in fact everything is running in the same container. Okay, you can even do this with Code Server, okay, which is an open source deployment of Visual Studio Code that can run as a server directly instead of installing it on your desktop. So here it will take a little time, just a few seconds, to load indeed Visual Studio Code, and that's what you have now in your environment. Again, connected into the exact same environment, and you have everything at your disposal. So again, as you can see, it's a great way to make all those modules that you have validated, that you are sure have passed your security requirements or your compatibility requirements as an organization, and provide them to all your users, okay? And then they are able to load them. Of course, you will ask me, okay, but maybe I don't want to load all of those modules every time, clicking on load. Of course, here, let's say this is your favorite installation of everything. You can save this configuration as a collection. This is what you can do here. I can create a collection. I will click on it, and I will call it demo. Okay, let's save this. This is my collection that has been saved. I will manually unload all the things now, just to give you an idea on how this works. I will unload RStudio and Java, which was the latest one. And let's say this is my environment when I open my session. There is nothing in it, but I can directly restore a collection, and I can choose from this drop-down list. Of course, there is only one that we have saved right now, and I can just click on restore, and it will load directly for me all the needed modules. So all the modules that I like, that I work with generally, and everything is loaded and ready to use for me. Okay. Of course, this is an example that is done inside a Jupyter environment, but this is applicable to any kind of container. So what you only have to do is to connect your persistent volume, your library persistent volume, to your container image when you are spawning it, and then the libraries are available. Of course, to load them, you would need to do some programming, but that's really easy. That's in fact a very simple Python code, and this Python code is available directly when you click here. You can generate the Python code that you need, and this is this one. So let's say I have a container image where I want to load the exact same version of the libraries that I used when I developed my algorithm, my notebook, and everything. Again, I just have to connect my library to my container image, and then run the small Python code, and then all the libraries, all the applications that I have loaded, that I want to be loaded, will be it will be done instantly inside the container image. Okay. Again, remember, this is not only for Python libraries, can be any kind of executables that you want to run. Here, for example, you have ffmpeg. Let's say you would just want to do some video encoding, or working on some audio and things like that. You would need this library to be able to run the code. Of course, this is a secured environment. You cannot do an apt-get install or yum install or whatever, because you're not supposed to be root inside those kind of shared environments. But here you just have to load your ffmpeg library, and it will be available for you directly in your environment. Then you can make all those calls to directly the application to ffmpeg. I hope you liked this presentation and the demo. You can find the full source code and instructions on my GitHub repo, and please feel free to contact me if you have any questions. You can visit our different websites or watch our videos to learn more about our ML capabilities. And of course, please contact us to discuss how Red Hat can help you with your data science needs. Thank you.